We'll move to the third chapter. Earlier used to be gravitation, which has been taken off from your syllabus. Okay, so we have a chapter now called work, energy, power, which was there last class also, means last academic years. But what has been additionally introduced here is machines, which were never taught in CBSE. ICSE used to teach that. Now, in order to start this chapter, we have a lot of time, okay? This chapter has been actually taught in a very hassle manner. The same chapter will be there in grade 11. So before we start this chapter, we have to dive into two concepts. One, mathematical concept of trigonometry, basic, which is there in your grade 10. This is one that we're going to dive. And the second one we will dive is a little bit on vector algebra. So we may need two classes to understand these two, and only then we will be getting into the chapter. Okay? I don't think in any class or any school this chapter has been taught. So pay utmost attention. This is very interesting and very enjoyable. Trigonometry. Trigonometry comes from the word tri, means three, gono means angle, and metry means measurement. A science that was prevalent in BC period with the Greeks. Those days we never had someone called as a mathematician. People were known as philosophers. A philosopher is one who is going to talk about society affairs, who is going to talk about king, who is going to talk about science, whatever was known, as well as mathematics. So philosophers like Archimedes, Aristotle, these were all philosophers. So this story goes to that time. And this is so accurate measurement that they could, an approaching navy, if you see movies like Troy and all, they could calculate by what time that approaching navy will be coming towards our fort. So see, and if archers are shooting arrows, whether the arrows are within the range, otherwise the arrows are going off, is a shot in vain, right? So let's understand what is trigonometry. At a basic level, trigonometry concept is applicable always to a right angle triangle. We will study this again in grade 10, but if you know now, you will be able to solve many competitive papers also. It is applicable only to a right angle triangle. So let's see. I don't know if I use the board here, does it make it more easy to see, or if I use it here? Okay, let me use it here. Not necessary that you have to draw it in this way. You can draw it in any manner, any orientation. Just make sure it's a right angle triangle, and you have a right. Okay, and let's name this triangle as something called, say, PQR. You can name it ABC, XYZ, whatever you want. All right. Now, a few names. Fine. Right angle triangle is done. After that, see, get some concepts correct. Once you have drawn your right angle triangle, try to always position yourself at the right angle, and then the side that you see right opposite to the right angle, isme dhyan dijiye, the side that you see right, I'll give you some time to draw, don't worry. The side that you see right opposite to the right angle is hypotenuse. Okay, it's known as the, sorry, this is the longest side of the right angle, and this will be known as my hypotenuse. And then we are left with two other sides, right? We are left with two other sides. So obviously one becomes what is known as an altitude or height. Altitude. Many call it height. Okay. These are all trivial names. Many will also call it perpendicular. However, all these are when you actually name this side as base. Because the triangle is right now sitting on a base like this. Now, if you would have little bit, say, pivoted this around this corner, then you don't have actually a base, because this side. Then if I would have made this as a base, this becomes my altitude and this becomes my height. So there will be a little bit of confusion which we will clear. So do you know a right angle triangle? A right angle triangle will always have a hypotenuse, and this is known as the longest side. Longest side. Right? So a 3, a 4, and a 5 is called a Pythagorean triplet, and this is a smallest right angle triangle that you can make. 3 square is 9, 4 square is 16. Add up, this becomes 25. 5 square is also 25. So 3, 4, 5. Is this understood? Yes. Any query up till now? Okay, fine. Right. Okay. Next. हो गया? Then angle. An unknown angle in trigonometry, we either represent it like this, like the word you write, the cursive letter O. O. This is a Greek letter which stands for the word theta, theta. Okay. This is a Greek letter. So how do you write it? You just make a cursive O. You just make a cursive O. Just make a cursive O. Now, problem is that, sir, we have never learned cursive writing. I can't help it. O and just pull it. That is known as the Greek letter theta. Fine. Which means that an unknown angle, say this is an unknown angle, and I can represent this angle with theta. Theta. Got it? Okay. Now what you do, you position yourself here, the unknown angle. Sir, you took this one. Could we have taken this one? Yes, you could have taken this one also. You could have taken this one also. Any unknown angle. So this, you have positioned yourself as theta. Now once again, the job starts. Now once you are positioned here, once you have positioned yourself here, try to look at the side which is right opposite of theta. Try to look at the side which is right opposite of theta. And this particular side will be known as opposite side. Opposite side. And you will get this by heart. This is the nomenclature you will follow. 90's opposite is known as hypotenuse. The angle on which you are concerned, right? You are concentrating on this angle. Opposite of this angle will be always known as opposite. So hypotenuse gone, opposite gone, one side remains. That side is named as adjacent side. Adjacent side, because it is very next to theta, adjacent to theta. This actually eliminates the confusion between who is perpendicular and who is base, right? Now you will say, sir, what great thing did you do by doing this nomenclature? Now you will understand what great thing was done. Suppose your triangle is given in this orientation, right? Let's say this is a triangle ABC and I have 90 here. By my previous understanding, to locate the hypotenuse is very easy. But how do I know which is base and which is altitude? $1 million question. So in this question, what I do, I freeze any one and I say if this is theta, then obviously this becomes opposite side. Okay, opposite side. And this becomes adjacent side. No, base is gone. We will not use that word base. Opposite side, adjacent side, and hypotenuse. Till here, do you have any confusion? Given a right angle triangle, the opposite side of the right angle is known as the hypotenuse. Any of the angle you freeze up, you're concerned. Now, if say Rishika would have said, sir, I take this as theta, then for her, this will be opposite side. And if you are taking this, sir, I will take this as theta, then you are idiot. This is already 90 degrees. Why do you need to take it? Is this clear so much? So 3 new names you have got. What are the new names? Adjacent side and theta. Adjacent side, opposite side, and hypotenuse. 3 side आपने सीखा, right? So you will not call out. I'll then tell you also. Like when we used to study, when I used to study trigonometry, I have studied it with perpendicular and base. Maybe many of your parents have also learned with perpendicular and base. Where the confusion arises and how to mix up the two systems also we'll see. You mopped the whole school floor. You did mopping of school floor today. Then, you know chicky. All of you know chicky. Chicky is made of jaggery and peanuts. I don't mind. Bring it here. Put 1 cube of chicky in your mouth. You will not feel hungry for at least next 1 hour. 1 cube. And it is all good. At your age, it's a darling food. You have peanuts. If you are unable to chew, that means your dental condition is bad. And you've got a little bit of jaggery, जो आपको बहुत energy देगा. खाया करो यार. ठीक है? Done. चलें आगे. So, then we understand something called trigonometric ratios. Trigonometric ratios. Don't dive that deep into it. trigonometric ratios. So there are three principal ratios or three main ratios, and three are reciprocal of these, plus three reciprocals. Three reciprocals means you have ABC, three ratios, DEF are corresponding reciprocals. We will not study all these. As of now, we will not put our head into this, but I'll tell you some names also. Out of these three also, for us, more important is two of three. At a grade 9, now we are doing what? We are just dipstick study, right? Three of them. The first trigonometric ratio is known as the sine ratio. Sine. So we read it as, and this mathematically will be written as sin. So many people study it as sin. It's not sin, it's sine, right? So look, now don't write. See what I'm saying. We actually take sine is a ratio. So we say sine of an angle. Sine of an angle. And let's say that angle is theta. So mathematically we show that as sine theta. Slowly, as you become senior, you will be starting to write it as sine theta. This is a function basically. There is theta. Sine theta will do some adjustment. Now, little bit knowledge about function also you should know. What is a function? You will see in many higher grade books, they'll write this word fx. A function is something like a magician's spot. A magician's spot. Functions can be trigonometric, logarithmic, inverse trigonometric, okay, exponential. For us, easy way is to understand an algebraic function. Let's say we have a function which says f of x is 2x. So this function is a 2x function. Understood? Whatever you enter from this side, this is going to process it as 2 and give you out. So if you enter 1 from here, the output will be 2. This is a function. If you enter, say, half from here, you get 1, right? And if you enter a dog from here, you get 2 dogs. X is the input. Understood? This is a function. So trigonometry is also a type of a function in which there will be certain values for some angle. So out of that, sine is one function. So this is called sine function, written as sine theta. Now let's again make our triangle. Now I'll deliberately make my triangle on this side so that you get a little bit confused, and then only you will learn. So my triangle is, say, P, Q, R, and hold, wait for me, right? I will be taking this as theta. I want you to take this as theta after you learn, and then you will write what is sine. Okay? Sine of an angle, sine of theta, I've taken this as theta, is always the ratio of opposite side upon hypotenuse. Do you understand? Opposite side upon hypotenuse. So in my case, in my triangle, it will be QR divided by PQ. Can you tell me that if you take this as theta, what will be your sine? Your sine will be this divided by this, because the hypotenuse doesn't change. See, hypotenuse is frozen. It is the longest side. The perspective of opposite changes as you swap the angles. Yahan khade rahoge, this is opposite. And if you are standing here, then this is opposite. Is this much understood or not? So this is called the sine ratio. When you can write sine. Sine of an angle is said to be the opposite side by hypotenuse. Now why we need it? Because when we do works formula and works problem, advanced problem, at that time understanding of this is very, very required. Though you will not handle sine in grade 9. Okay? Clear? Our next ratio is known as the cosine ratio. Yeah, cosine, which mathematically is written as cos. Yeah, we say cos, but if you see an American teacher, they will never say cos. They will say cosine. Cosine. We say cos, they'll never say cos. They'll say cosine of the angle. So cos theta is always said to be the ratio of adjacent side upon hypotenuse. So in my case, my cos theta becomes now PR by PQ. Now just see, since you swapped your angle, your cos theta is my sin theta is your cos theta. Because our perspectives are different, which angle we have taken as theta. So this is our second. Now it will come a little bit difficult. You'll say, I don't know which one is what. So now we'll give you mantra also. Once mantra is given, then you'll remember everything. ठीक है? अरे जबरदस्त मंत्र है, देखते जाओ. Then we'll learn the old way also. What you read as opposite side, in our days, this opposite side is actually known as the perpendicular. Did you understand? So if I write this as per my days of study or my grandfather and father days of study, yes, so this becomes perpendicular by hypotenuse. Now since then adjacent side becomes what, beta? Automatically it will become the base by hypotenuse. So we will give you a formula in which you will remember both, but any day this is better. In fact, when I passed my grade 9, then also I used to do it this way. Books used to teach little bit, books were still this way. My teacher told me to learn it this way. And later we found, I used to remember as opposite side by adjacent side, opposite side by adjacent side. I used to teach one girl here from Srinidhi school. She's now a lady, matlab, bahut saal pehle, in IB. And she taught me one formula, which I know, and that's what I'll share with you. And then it becomes very easy. She told me, why are you saying so many things? There's an easy way to remember. See, you learn from so many ways. I'll tell you that also. Ye ho gaya? Okay? And then there is a third ratio. Why I'm teaching the third ratio is that then it becomes clear for you, though you will not use it in grade 10. That is called the tangent ratio. Tangent. Tangent of an angle is said to be tan of an angle. So tan theta becomes opposite side by adjacent side. Very good. Opposite side by adjacent side means in my theta it will become QR divided by PR. And if I go to my grandfather days, then this will be known as perpendicular by base. Right? Sine is opposite by hypotenuse, cos is adjacent by hypotenuse, tan is opposite by adjacent. And if you go back to the grandfather days, base, if you go back to the grandfather days, then the grandfather days, the way they used to see is, they used to say like this. They used to say that, sir, how do you distinguish between what you call opposite side and perpendicular and base? So grandfathers used to say that the opposite side of theta, which you call as opposite side, they used to call it as perpendicular, which means here this is opposite side, this will be perpendicular. Then automatically this becomes base, because hypotenuse, I also say hypotenuse, my grandfather also said hypotenuse. ठीक है ना? चलें? Is this clear now? So let me rewrite them once again so that it becomes clear. The rewriting will give you sine theta is opposite side by hypotenuse. Fine. Cos theta is adjacent by hypotenuse. Tan theta is opposite by adjacent. Okay? Which is equal to perpendicular by hypotenuse, which is equal to base by hypotenuse, which is equal to perpendicular by base. Now, as I write this, what I'm doing is that I'm just circling this word, this, 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 this. Okay? So the formula that we say is SOHCAHTOA. Yeah, if you remember SOHCAHTOA, then everything is done. Is that what she told me? Right? She's now in near London. SOHCAHTOA. So sine is opposite by hypotenuse, cos is adjacent by hypotenuse, tan is opposite by adjacent. So that way you can remember SOHCAHTOA, 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 and SOHCAHTOA never fails. Okay. Now we will see some desi techniques also. How our days, our grandfathers used to remember. But that's a nice rhyme. No, SOHCAHTOA was not there. SOHCAHTOA came from, SOHCAHTOA is very recent, maybe some 7, 8 years, 9 years. Perpendicular and all, say my grade 9, 1991, 92 days. उससे पहले तुम तो अपने पिछले जन्म में थे. You were in your last birth. Okay. And you were yet to die in your previous. Obviously, if you believe in reincarnation. And then it used to be this one. Now, how people used to remember this? Want to know that? That's interesting. Look, there used to be a rhyme.
Some people have curly hair, curly brown hair. Perpendicular.
Black. You can go and tell any oldie person who is there and remembers mathematics. Some people have curly brown hair, turned permanently black. So this is how we used to remember. Sine is perpendicular by hypotenuse. Cos is base by hypotenuse. Tan is how much? Perpendicular by base. None of your schools will even disclose these things to you. Now there is, if you have studied in Hindi medium, then also there is a formula. Not like that. पंडित बद्री प्रसाद हर बोले, बाकी लोग सोना चांदी तोले. Sign becomes perpendicular. पंडित बद्री प्रसाद हर बोले, बाकी लोग सोना चांदी तोले. This is also a formula. If you want to, sin theta is perpendicular by hypotenuse, cos is. But life becomes much easier with this, I think. SOHCAHTOA. हर बोले, पंडित बद्री प्रसाद हर बोले, बाकी लोग सोना चांदी तोले. बहुत अच्छा है. ठीक है, समझ में आ गया? You understand now how to take cos and all. So, shall we? अच्छा, you're liking it. लिखो. Nice things should always be remembered. Desi tricks never die down. As I always say, how do you spell lieutenant is झूठ तुम 10 चीटी, है ना? Lieutenant, झूठ तुम 10 चीटी. That's called.
I told my friend.
Champagne is always champagne. Champagne. चले? Shall we? Okay. Now let us see applications of this quickly. Why trigonometry is useful for us? How does it help us? So you can actually do it also. Say suppose, why does it help us? How does it help us rather? Okay. Say suppose, this is my tower, B tower. Okay. This is my tower, titanium. This is my B tower. And I want to find out what is the height of this tower. I want to find out what is the height of this tower, right? So what I do, I take one of my friends, say I've taken Charvik along with me, and I say, Charvik, we'll tie one thread right at the edge of this tower and we'll peg it somewhere here. We've pegged it somewhere here, right? And I'd ask him, better go and get your protector. So we get our protector and we find this value, say this is measuring something 60 degree. So my theta is how much now? 60 degree, right? So, and let's say this is my height of the tower, and how much away from the tower? This is on land, I can always measure it. So I say that this is some B measurement. So I can now say that sine of 60 is equal to H upon B. Now, there are values for sine 60, sine 30, every sine has a value. There are some standard values which we should remember, and other things the calculator or the sine table gives you. Like I know the value, so my sine 60's value is a root 3 by 2, which is equal to H upon B, and say my B was some 10 meters, so I'm writing it as 10. So you can find out the height of my tower is root 3 times 10 divided by 2, which is 5 times of root 3. Which one? Root 3 by 2 standard formulas are there. Now that's the next thing we need to remember. Okay, so let's know some values. In grade 10 we will be using the cos. No, grade 9 in this chapter we will be using cos. So you should know cos for 0 degree, 30 degree. Okay, in fact, pardon me for this, but if I show you sine, then you will actually get the pleasure. Let's take both values, sine of theta and cos of theta, and thetas are 0 degree, 30 degree, 60 degree, 90 degree, right? This much, and keep one 180 also, which we use 0, 30. Oh, there's one more missing, sorry. There's a 45 also. There's a 45 also. 60 and 90. These should be, means in grade 10 anyway, you have to memorize for all the 6. 1, 2, 3, 4, 5. 5 into 6, 30 values. So 30 values no individual can memorize unless and until there is a trick. So people will first make you afraid that itna values, aisa kuch nahi hai, there's a trick. So sine, you don't need the signs in grade 9, but I'm writing it because you'll see some what do you call trend. Sine 0 is 0, sine 30 half, sine 45 1 upon root 2, sine 60 root 3 by 2, and sine 90 is 1. Got it? Now you need to know what is cos. Just write this whole thing ulta. 1 root 3 by 2, 1 by root 2, half, 0. Actually, if the two angles add up to make it 90 degree, the sine cos values are same. 0 plus 90 is 90. So you see sine 0 and cos 90 values will be same. 89 degree and 1 degree values will be same. 80 and 10 degree values will be same. So look, 30 and 60 add up to 90. So look at what is sine 30, what is this? So their reciprocals will also be obeying the same thing. Okay, na? At your grade, you should know this, generally they don't give, this they give, and this. Actually, if you know 5 values, you can create the whole table. Sine 0, 0, cos 0, 1. Sine 30 half, cos 30 root 3 by 2, sine 45, 1 by root 2. If sine 45 is 1 by root 2, cos 45 has to be 1 by root 2 because 45 add up to 90. Any two angles which add up to 90 is known as this. Understood? Acha. Some more interesting things. When you go to grade 11, you will be seeing there's a common triangle they will always draw for you. Very common triangle. All physics problems will be on this triangle. A right angle triangle. Okay. And this right angle triangle will be given measurements of 3, 4, 5. This is the smallest Pythagorean triplet. At this case, you know that this angle should be how much? 90 degree. An angle opposite to a smaller side will also be smaller. Just think like a crocodile. If your angle is small, the crocodile's, this distance is small. If the angle increases, this increases. So let's say I name this as A, B, C. Now tell me, between A and C, which angle should be bigger? C should be bigger because C is opposite to a bigger side. This is a unique combination in which this will be this angle will be 37 degree and this will be 53 degree. A 3, 4, 5 triangle can be constructed with a 37, 53 and 90. Have to be. पत्थर की लकीर है, होएगा ही. You can go home and make one right angle triangle with how much? 3 centimeter, 4 centimeter. If you are correct, then the hypotenuse has to be 5 centimeter. Otherwise, your angles are not 90. See, children, draw two perpendiculars and with a compass, you mark off at 3 centimeter and 4 centimeter. Join the two dots, it has to be 5 centimeter. Otherwise, your angle is wrong. Maths is very interesting. ऐसे पढ़ो ना. Got it? After you have constructed, see what I'm asking you to go back home and do is just do this thing. Draw a big line and draw another 90-degree big line. Correct? Take your compass and mark at 3 and mark at 4. Got it? And then join these two and make it a little bit bigger. This has to be 5. Huh? Oh, that is different. This is Pythagoras theorem, simple. This will be. Then you take your protector and you see the measurement. We said that this is 3, this is 4, this is 5. So this is 4. So this angle will be 53 degrees and this angle will be 37 degrees. So in grade 11, in many competitive exams, all the diagrams will be based on this measurement and you will land up something at cos 37. Sir, cos 37, they gave cos 37. That was an error in the question. They expect us to know cos 37 value. They didn't give us calculator. You are idiot. Cos 37 means the triangle is a 37, 53, 90 triangle, which means it's a 3, 4, 5 triangle. And cos 37 is very easy. Opposite side, adjacent side, cos is ka. Adjacent by hypotenuse, 4 by 5. But children cry saying that no trigonometric table was supplied, no calculators were supplied, and they gave us cos. Because they expect everything will come in 0, 30. That's a table which you memorize. You don't memorize what is 37, but this is a trick. 3, 4, 5 is the smallest triangle. And a 3, 4, 5 triangle will have measurements of 90, 37 and 53. Which one will be 37? Opposite to 3. Which one will be 53? Opposite to 4. Have you understood? All right. So in this chapter, there will be many instances where we have to find the value of cos 0, sin 0, 0, cos 0 is 1. There will be places where we have to find cos 30. Cos 30 is root 3 by 2. And your root 3 value you should know, it is 1.732. Okay. Then we should know cos 45, which is 1 upon root 2. Very rare they will give you this. They'll give you cos 60. Cos 60 is half. But generally in school levels, they will always, this is 1, so this is 0. They will always give you the value. They'll, in the question, they'll write, take cos 30 as so and so. Have you understood? The chapter does not discuss about what is cos. What is cos, the chapter does not say, but you should understand what actually is cos. Okay? Clear? Okay. Now, let us see one more interesting observation. Right angle triangle. Okay? Let me say that I don't know the measurement of this. Let's keep this as x. And I know the measurement of this, and I'm keeping this as h. This is my hypotenuse. Right? And I know the angle out here. The angle is theta. I know the value. So what do I write cos theta as? Cos theta is x divided by h. Right? This gives me the ability to calculate the value of h as x as h cos theta. Okay? H cos theta. X is this much. H is this much. Now what I'll say, understand it properly. Take one lamp and illuminate the lamp from here and think that this is a bar. How much of the shadow will you see? Only this much. Do you agree or not? Do you agree? Okay. Second perception. Forget that this is a lamp and forget that you're an Air Force fighter and your fighter aircraft is here and you are at the ground. You see this is a hill because you see the elevation. Titanium is seen as a tower in front of us. But if I'm on an aircraft and I'm seeing like this, I see titanium just as a square. Got it? That is called the plan view. And when you see from front, that is known as the elevation. Right? So if you're on top, how big do you see this? You'll see this as big as this. This is known as the projection of H on X. Cos theta, H cos theta, not H. This is X. Do you agree? This is H cos theta also. So what is X? X is the projection of the hypotenuse on the base. If seen from top, the projection of the hypotenuse on the base is X. Are you understanding? If you see, the Himalayas are like this. If you are on top, can you see the Himalayas as like this, like this? No, that we can see only when we have seen from the front side. Let's take one more example. Let's say we have a hexagonal nut. This is a hexagonal nut, right? Now, when you see the plan of the hexagonal nut right from top, you see the circle, you see the hexagon. If you see from this side, you will just see like this. दूर से तुम्हें कैसे पता वो ऐसा ऐसा हो रहा है? How do you know? You are in a far away place. So when we do this drawing in engineering, this is called the side view. And if you see from this side, you see the hexagon as these. You'll see just like a straight side. Do you agree?
Yes.
I have curved my mobile and I'm holding in front of you. Don't be biased. Try to see from here. You will only see it like a straight line. How do you know that it is like this? I know that because I'm seeing from top. Therefore, whenever we design anything in mechanical, we give a plan view. Civil engineers call plan. That's why when you buy a flat, you always say plan dikhaiye. We mechanicals call it as top view. Top view. This is called front view. Civil engineers call this as elevation, facade. How is the building? And we call it side view. They call it column view. Column view means if you break out the plaster, you can see the column of the building. That is called the column view or the end view. Okay? So what is a H cos theta? H cos theta is nothing but the base. A base is always the projection of the hypotenuse. That's the beauty of cos theta. That's all. Got it? Now you will say, why am I teaching all these things to you? And what is the use of it? Though I will not tell you the mathematics, what is the use of it? Itna hamara dimag kyun khaya sir ne? So this, when you were kiddos and you used to cry, then your parents used to buy you a toy car. Do you agree? And this is you. And you used to pull the toy car like this. But the toy car always used to go like this. Where is the force? How is the force acting? So that we will learn in vector. The force is actually pulling the toy car on this side, but the toy car is not getting lifted. That means this force is somehow getting split. The actual force felt is on this side. So if this force was F, this force is F cos theta.
Oh, wow.
Which you need in work, which your book will just say use F cos theta. But what is that goddamn cos theta? You don't know. These I keep in my mind when I come to teach you. Then only you will understand that you're pulling it. So you have to understand which force is pulling the car. The car is not being pulled by F. The car is being pulled by F cos theta. Then where did the other part of the force go? That we will understand in vectors. How force is a vector. To understand work, work is a child who is given birth by two parents. One is force, one is displacement. Both are vectors. So vector algebra भी समझना है. ये चीज समझ में आया? I'm carrying my watch today. I don't know what is the time. Okay, we still have time. So these sort of scenarios will come. Take. And if you see the displacement vector, the displacement of the car is also happening in this direction only. Okay? Remember this. Displacement, the word in the direction of force. I'll be keeping on saying this in this chapter. Displacement in the direction of force. So if you don't know what is the direction of force, but you know that the displacement is happening here, there has to be a force which is along this direction. Otherwise, वो जा कैसे रहा है? How is he going? Got it? चलें, इतना ही जानना था हमें. So if you want to write any values or anything, 2 minutes to you. So please, you should know the values, whether they give you the values or not. We will be using only cos in grade 9 and we should know the value of cos 0. हमें 10 में है. अच्छा, एक और वैल्यू हमने लिखा नहीं बेटा. There is that 180 gone. Yeah, I said that there should be a 180 also. And just cos 180 is minus 1. You remember this. Cos 180 is minus 1. साइन जरूरत नहीं है अभी आपको. वो आपको जरूरत है, बता सकते हैं, but it will not help you. Cos 180 is minus 1. Everything. With trigonometry, you can also find out that there is you waiting outside, right? And at your age, wala problem. And then there is a what do you call, your boyfriend is coming in a car, and there is a judgmental auntie who is watching both of you. Knowing the speed of the boy, the judgmental auntie can predict by what time he will come and he will show your face outside. आप तो खड़े नहीं रहोगे ना उसके सामने, आप भी तो टाइम मिला के बाहर आओगे. So that is called the judgmental auntie problem. Judgmental auntie can predict by what time that boy will come and this one will come out, or whether this arrow will hit that particular crow or not. All these problems we can do. Work, energy and power. Work, energy and power. This chapter will be talking a lot about machines also. Machines is a new introduction, but work को समझने के लिए, because in grade 11 otherwise you will be limping in this topic. The same chapter is there in grade 11. Work, energy and power. Then you will understand electrical work, mechanical work. वो सब में भी गड़बड़ होगा. तो अगर आप वर्क ही नहीं समझोगे, then how do you understand later? Very good. चले, how much is the time? Okay, 22. Little bit of vectors. Chalo. Let's go a little bit of vectors. Vectors. Vectors are quantities which have got both magnitude, and vectors also have direction. Do you agree? The easiest way to represent a vector is actually by an arrow. Right? Where the length of the arrow corresponds to the scaled magnitude. Now say, suppose I say there is a force of 50 Newton. अब तुम 50 meters का थोड़ी arrow बनाओगे. So you will say let 10 centimeters represent 1 Newton, right? So 10 newtons be represented by 1 centimeter. So 50 newtons, how much arrow I'll make? 5 centimeters, right? And the arrowhead points to the direction. Direction means, and this is the origin of the vector. Understood? So I have a vector. I have this as a vector. This is my vector A, and we write A as like this. Vectors are studied both in physics and maths. So this is A vector. The easiest vector to study is force, because you feel it is going this side, it's being pulled this side. This is A vector. And let's say I have another vector. Which is a vector B, right? Two vectors are said to be equal to each other. A vector A is equal to a vector B if, this is IFF. This means if and only if in mathematics. If and only if, right? the magnitude of a vector, magnitude is always written as modulus, is equal to the magnitude of b vector. Children, I'm not saying anything great. Two forces are said to be equal if this is also 5 Newton, this is also 5 Newton, and the direction are the same. 5 Newton east and 5 Newton west are not equal vectors. They are equal by magnitude, but not by direction. Understood? So, vectors have one very interesting thing which is known as parallel translation of a vector. What do I mean by that? थोड़ा सीख लेते हैं. ये सब कुछ भी आपके बुक में नहीं होगा, लेकिन if you know this, it's easy. So let's say this is a vector. You are allowed to parallelly translate. Now again in CBSE you don't know what is translate. There are three types of things we do: rotation, transformation, make him bigger, translation, move him wherever you want, same size. This is called translation. But anyways, I'm just think that this part is also there. Okay, this is called a parallel translation of vector. You can take the vector and you can move the vector wherever you want, but parallelly. They all mean the same. Have you understood? You are allowed to do this if this is a vector. So that means if they put another vector out here whose length is same as this, and the vectors are parallel, they ask you, is this equal to this? Yes. You can translate and superimpose one vector on the other. Clear? However, they are parallel, but the arrow is pointing this side, this is on that side. You can't translate. Translate means same thing as bingo to bingo. Got it? Right? ये basic लिया. How much time do we have? थोड़ा time है. हो जाएगा. आओ. We need to understand something called vector multiplication in this chapter. Vector multiplication. There are two basic forms of vector multiplication. The first one is known as scalar product, and also known as dot product. Vectors can be multiplied in two ways. Means suppose I have a vector A and I have a vector B. Don't put the multiplication sign. They can be multiplied in two formats. The other one is known as vector product. Sir, what is the difference? This is known as cross product. If I multiply the two vectors here, the child who will be born will be a scalar. If I multiply the two vectors here, child will be a vector. Got it? So this multiplication is shown like this: A vector dot B vector. We don't write it as A vector into. This is shown as A vector cross B vector. Okay? This is a scalar. Means the child who will be born will only carry what? Magnitude. The value of this is modulus of A into modulus of B, absolute values. So if you say minus 40's absolute value is 40. Absolute value is always positive. Sir, there was a force of -2 Newton. But the magnitude is 2 only, na? Multiplied by cos of the angle between the two vectors. That's why cos theta was taught to you, which means it is like this. Which means it is suppose this is A vector and this is V vector and this is the angle theta. Sir, my A and B are too far apart. Parallel translation and join them. So you get a theta. And now if this angle is 0 degree, 30 degree, if this is 0, then this value is 1. If this value is 90, this value is 0. If this value is 30, this is half. root 3 by 2. If this is 60, it is root 3 by 2. Now half. And if it is 45, it is 1 by root 2. Understood? So this is a scalar quantity. This is a scalar quantity. What we are going to study work will also be a scalar quantity. Work is a child born by two parents, force and displacement, but the product will be dot. Therefore, what you get is work, and work is scalar. तो अब ये देखते हैं ये क्या है. This is always another vector C, whose value is, now the value, you don't need the value also, A B sin theta. अब डायरेक्शन कैसे पता चलेगा, इसलिए टाइम तो 5 मिनट 2 मिनट दो. डायरेक्शन कैसे पता चलेगा? हाउ डू यू नो द डायरेक्शन?
arrow.
It's very easy. Wait. Acha, later in 12 we'll study A dot B and B dot A are same. So it is commutative. Dot product is commutative. End of the day, you are getting a magnitude only. Now, how does it differ? 3 into 2 or 2 into 3? And direction differs. Huh? This is not commutative. You'll see that. और ये थोड़ा मुझे टाइम दो, बता देता हूँ. A, B, theta. Now, what is the plane containing A and B? My screen. Screen is the plane containing A and B. The C vector child will always be perpendicular to the plane that contains both this. The C vector will be perpendicular to the plane that contains both A and B. That means C can either come out of this screen or go inside this screen. This is the plane containing A and B. So C vector can be either like this or it can be like this. Question arises, what is then the direction? दोनों तो नहीं हो सकता है. So what are we doing? A cross B. This is called the right hand thumb rule. Put your hand on A and you are crossing A with B, right? A ko B you are crossing. Where is the thumb pointing? So the C vector is towards you. But if you do B cross A, then put your hand on B and curl it towards A. Now where is my thumb pointing? Inside. So A cross B is coming out, B cross A is going this side. And when you use force and displacement and make a cross product of it, you give birth to a quantity which is known as torque. That's torque. So look, beautiful. Now, this is a vector. Now, if you turn your screwdriver, how will you open a screw? This way. So, this is going this way. The torque is coming which side? This side. So, the screw comes out. That's why. And if you want to tighten the screw, then you are doing B cross A. Screw goes in. Physics is interesting. So it comes out. This is called the corkscrew rule, which we use on those wine bottles or champagne bottles. Have you seen? Or we call it as the right hand thumb rule. You have got in magnetism left hand thumb rule, right hand palm rule. So many rules are there. So right hand thumb rule, take your right hand, the thumb to be at 90 degrees with your finger. A को B के साथ cross and C. So A cross B is not same as B cross A. In fact, to make you a little bit understand, let's say this is a plane and this is a vector and this is a vector. This is A and this is B. A, B. So it will come out. It will come out. It will come out somewhere like this. C vector. It will coming out. So we have to see it in 3D. So it's not so easy. Screen से बाहर निकलेगा. So this is what you should know in this chapter. What is the unit of force? Newton. What is displacement? Meters. So what is the unit of work? Newton meters? No. Newton meters is the unit for torque. Therefore, when you see a new car ad, you will see the new Honda City 5th generation gives you a power torque of 29 Nm. A rapchick lady will come, but she will say Nm. She doesn't understand what is Nm. Nm is actually Newton meters. It's talking about torque. And here, what is the unit? Work is same as energy, which we all will learn. So this unit will be joule. Never write Newton meter. Newton meter is for a vector product. Joule is for a scalar product. Whenever you say Newton meter, there is a direction associated with it. Who have to understand has understood.